Okay, we're going to look at section 2.1. And the first part of this first video is going to cover relations, domain range, functions, and some function notation. So the first thing that we've got is that a relation is any set of ordered pairs. Now, when we think about a math class, we think about ordered pairs, we think about things like 3, 4, 5, -2, things like that. It doesn't have to be. It could be last name, first name. It could be last name, number of pets, any combination of things like that. Now, the domain is the set of all first elements in the ordered pairs, and the range is the set of all second elements. Now, when we do think about traditional ordered pairs, X, Y ordered pairs, the domain is now your set of all X's, and your range is now your set of all Y's. So we're going to take a look at this first example, and I'm going to get this transferred to my board here. Okay, so we've got 0, 9.1, 10, 6.7, 20 and 10.7, 30 and 13.2, and 40, 21.2. So I'm going to go ahead and stop that share. Okay, and so when we look at this and we want to talk about the domain, since these are individually given points, that I'm just going to individually list the values. And I'm going with these first values right up here in each one. So I have 0, 10, 20, 30, and 40. Now later on, we'll talk about how to do this if it's not individually given ordered pairs. If we have things like coming from graphs or function equations, things like that. Now, if we're going to talk about the range, okay, again, individual points, we're going to pull all of these second values back here. So I've got 9.1, 6.7, 10.7, 13.2, and 21.2. Excuse me. Okay. And no, I did not put them in order from least to greatest. Some do require that. For this one, I just wrote down what they are. Now, the other question also comes up, what if a value is repeated? So let's say for this first one that I actually had, this was actually a 30. If that was the case, then my list would have stopped right here at 30. You do not have to write it down twice. Once it's been written as an element in either the domain or the range, then it's included as part of it. So you don't have to worry about trying to write it down as many times as you see it happen. Okay. So now the next thing that we're going to look at is going to be, what does it mean to be a function? Okay. So a function by definition is a correspondence between a first set or a domain and a second set or a range, such that each element in the domain corresponds to exactly one element in the range. Now, basically what we're looking at here is we do not want our x's to repeat, and that's the big thing. We cannot let x's repeat in order to be a function. If our x's do repeat, then it is no longer a function. So if we're given things that are in lists, like what we just saw, or we're given a table of values and things like that, then we're only going to have to look at those x values in order to decide whether or not it is or is not a function. Now, the other thing that we're going to look at over the next couple of examples is we're going to talk about functions as equations. How do I know when an equation is or is not a function? And then we'll also look at some function notation. So the next example I have already written down on our board here. And so when I'm looking at whether or not this is a function, the only thing I'm going to focus on are these x values. So I have 1, 3, 6, and 8. So since all of those values are different, yes, this is a function. Now, you may be telling yourself, but wait a minute, I see that 5 is listed twice in that one, but those are on the y values. Again, in order to decide whether or not something is a function or not, we are only concerned with the x value portion of this. Okay, so now the next thing that we're going to take a look at is what if I'm given an equation. Okay, so the particular one that we're going to look at is x squared plus y squared equals 1. Now, when we talk about deciding whether or not an equation is a function or not, I need to get it into y equals. Okay, so the first thing that I'm going to do with this is I'm going to subtract x squared from both sides. So now I'm going to have y squared equals 1 minus x squared. And now in order to get rid of the squared here, I'm going to need to take the square root. Now, back when you first learned about square roots, and I'm going to put a pause over here on this real quick. So when we first learned about square roots, okay, and you were given something like square root of 25, your first instinct response is 5. And the teacher would go, very nice. And then they'd say, and then they'd wait. And they would say, or. And you'd sit and think and go, well, five's the only one. It's not any other numbers. And then it would pop out that it could be -5. Because what we're looking for here is I need a number times itself gives me 25. And certainly 5 times 5 gives me 25. But -5 also, when I do -5 times -5, also gives me 25. So if I'm coming back down out of the square root, I don't know which one they wanted to go with. So when we do this back over here in our equation, I don't know if they wanted me to take the positive or the negative, so I have to give them both. So we're going to say that this could be plus or minus this square root. Now, you may be going, okay, well, that's fine. Okay. But now, what if I let x equal 0? Well, if I plug that in, I'm going to plug in 0. Well, 0 squared is certainly 0. So I have that that's that. And that's going to be 1 or -1. Now, here's the concern. That now means I have 0, 1 and 0, -1 as ordered pairs. And now I have repeated x's. So this is not a function. Now, the helpful thing here to know is the reason that this was created was not a function is because of this plus minus right here. The reason this came in was because I had to get rid of this squared value right up here. Okay, so the big red flag is going to be if you see y squared in an equation, it's probably not going to be a function. Okay, now if you see things like you're probably going to be pretty good. Okay, and you can certainly check a couple of values and see, but take any number, multiply it by 2, add 7. You're not all of a sudden going to wind up with 2 different answers. Even if I have something like this, if I take a number, 5, and I square it and then run it through here, if I take -5 and plug it in, I'm going to get another answer. I'm not going to have that it gives me 2 different answers. So both of these would be functions. Again, the big red flag is the fact that I had a y squared in that previous example that we worked through. Okay? Now, the last thing that we've got to talk about for this particular part of section 2.1 is we're going to talk about function notation. Now, when mathematicians were first moving around, they would have lists of things. Okay. Okay, so they have these big long lists, and then they would ask, what is y when x equals 2? Okay. Well, now here's the problem. Which one am I talking about? Okay, do you know which one of the equations that I'm asking you to plug in? And you might be looking at some of these going, when did we start putting lumber and evil things into math equations? You may already think math is evil, but so what mathematicians did is instead of writing y equals y equals y equals y equals y equals, okay, they came back and they said, instead, we're going to use this thing called function notation. And basically, everybody is going to get a different lettering, okay? So now, instead of all these being y equals, this is now Fred and George and Henry and Rob and Mark, okay? So now, instead of asking this question, if we use the notation f of 3, this tells me two things. Number one, it tells me which equation you want me to use. Secondly, it tells me what value you want me to plug in for x, okay? So now, taking a look at an example of one of these. So we've got f of x equals x squared minus 2x plus 7. And they want us to find f of negative 5. Okay? So f of negative 5 is, now I encourage the use of parentheses when you're plugging in for your value, just to make sure that you do correctly do the algebraic manipulation that needs to happen here. So negative 5 squared, it's going to be negative 5 times negative 5, which is 25. I've got negative 2 times negative 5 is going to be 10. And then plus 7. 25 plus 10 is going to be 35, plus 7 is going to be 42. So f of negative 5 is 42.